Again, so my sleep cycle is not really good. I don't know what to do with that. I'm trying very hard. थोड़े दिन सही होता है, and then again I'm back to my. How can I explain it? Anyways, so let's go, baby. Let's start what we were doing. Okay. Um, I think I should fix that first. Oh yeah. No, it's fine. Where we were learning chemistry. Chemistry. I think chemistry is not very much favorite for so many people, I guess. But I like it. Let me know if anybody is fan of chemistry. Uh, where we were? Yes. So we were learning SI unit from last. I just give me a minute. I just wanted to. Yeah, we had some exercise. We had completed some exercise. Okay, so what we were learning, we had learned this, and then length and mass, the SI based unit. This also we have learned. Then temperature. So what we have learned in temperature in we have three types of scales: degree Celsius scale, Kelvin scale, and Fahrenheit scale. So degree Celsius scale is based on water freezing point and water boiling point. So degree Celsius scale start from water freezing point. When the water freeze, that temperature is called 0 degrees Celsius, and the water boils, that is called um, what it called definitely the 100 degrees Celsius. And Kelvin also has the same unit of degree. What should I call? Yeah, I mean it just that it start from absolute zero, which is minus 273.15 degrees Celsius. Since we are very familiar with degree Celsius, that's why I'm explaining it. So see, at zero temperature, water freezes, and we are aware of it. This temperature is. So from this temperature, we go to minus 273.15 degrees Celsius, which is called absolute zero. I think it's the practically attainable temperature, I guess. The lowest attainable temperature. Yeah, this is so it start from here, and yeah, but then what the Celsius and Celsius and Kelvin scale have equal size unit. Yeah, equal size unit. That is a Kelvin in the same size as a degree Celsius. Thus, the Kelvin and Celsius scale are related according to. So basically, if you want to calculate the degree Celsius and Kelvin, what do? You add 273.15 into Celsius scale, and then it becomes Kelvin scale. Kelvin's value. Like if I say if I say this water has a 4 degree temperature, means if you wanted to convert in Kelvin, you just have to add the 273.15 into 4 degrees Celsius, and then you will get the Kelvin's temperature, Kelvin scale, Kelvin unit temperature. The freezing point of water is 0 degrees Celsius, is 273.15 Kelvin. Yeah. So we can say that also, that in Kelvin scale, water freeze on 270 to 73.15 Kelvin. Okay. Notice that we do not use the degree sign in temperature of the Kelvin scale. Yeah, definitely. I shouldn't. I should have. I don't know if I have. If I said the degree Celsius or degree Kelvin, I think degree. We just say Kelvin in the Kelvin scale or Kelvin value. Common temperature scale in the United States is Fahrenheit. Now we have the third scale, Fahrenheit, which is not generally used in science, but I think we use. Okay, just excuse me. Water freezes at 32 Fahrenheit and boils at 212 Fahrenheit. The Fahrenheit and Celsius scales are related according to. So degree Celsius is equal to 5.9, and then what was this, Fahrenheit minus 32. Yeah, Fahrenheit minus 32, and then if you calculate the Fahrenheit, I mean Fahrenheit is equal to just value ulta कर दो 9.9 by 5 degree Celsius plus 32. Yeah, so here they ask whether the Kelvin scale and Celsius scales have the same size of degree. So yes, Kelvin and Celsius have the same size of degree, but the Fahrenheit is a different size of degree. Definitely, we already calculated that, so we not gonna calculate it again. Go figure. I think we should see this. How many 1L bottles are required to contain? How many 1 liter bottles are required to contain 1 cube for liquid? I think I should read once again. How many 1 liter bottle are required to contain 1 cube for liquid? So 1 meter, 1 meter, and 1 meter. Okay, one, two, and three. Three-dimensional. dm square is equal to 1 liter. 1 q is equal to 1 liter. One. The volume occupied by cube 1 meter on each edge is 1 cubic meter. So one each cubic meter contains 1,000 decometer. Hmm. 1 liter is the same volume as 1 cubic decimeter. Derived SI unit. Okay, now we're gonna learn about derived SI unit. SI based unit. I think SI based unit are used. The SI based unit are used to obtain derived unit. To do so, we use the defining equation for the quantity, substituting the appropriate base unit. For example, speed is defined as the ratio of distance traveled to elapsed time. Okay, so thus the SI unit for speed, SI unit for speed is equal to m is equal to s. M. What was that m? Small m, milli per second. Distance per second, meter per second. Okay, meter per second is derived unit. Meter per second is derived unit. The SI unit for distance, length m, divided by the SI unit for time is. Two common derived unit in chemistry are those for volume and density. Two common derived unit in chemistry are those for volume and density. Okay. So derived units. Speed. SI unit of speed is equal to ms meter per second. Volume. The volume of a cube is its length cubed. Length to the power 3. Okay. Thus, the derived SI unit of volume is SI unit of length m. Rise to the third power. Okay. The cubic meter is the volume of a cube that is 1 m or on each edge. The smaller unit, such as cubic centimeter, sometimes written cc, are frequently used in chemistry. Yes. Another volume unit used in chemistry is liter, which equals as cubic decimeter. dm decimeter, deci. Where is deci? Yes. Decimeter. Hmm. Smallest unit such as cube centimeter, sometimes written as cc and frequently used in chemistry. Another unit used in chemistry is the liter, which equals a cubic decimeter. dm cubic, and it's slightly larger than a quart. Cubic decimeter, and it's slightly larger than a quartz. A liter is the first metric unit we have encountered that is not an SI unit. What? The liter is the first metric unit we have encountered that is not an SI unit. How? There are 1,000 milliliters in a liter, and 1 milliliter is the same volume as 1 cm square. Acha. So what is C shade saying in volume is equal to cubic meter. M. Deliver variable volume, graduate cylinder ml, syringe, stopcock volume to control the liquid flow, burette, pipette. One smallest unit such as qubits. Is equal to M3. V cubic of a cube is that 1 meter on each edge. Smallest unit such as cube, centimeter. The smallest unit such as cube, centimeters. CC are frequently used in chemistry. Another volume unit which is uses liter E with equal as cubic decimeter. Decimeter, okay. 0.1. For the cubic meter equal as cubic meter. D and 3 decimeter. This is slightly larger than a pointer. Liter is the first metric unit we have encountered in the RNA assignment. There are 1000 milliliters in a liter. Hmm. In a liter, and 1 milliliter is the same volume as 1 cm square. See, 1000 ml is equal to 1 liter, right? Now, what is they're saying? 1 ml is the same volume as 1 centimeter cubic. Mhm. What do we use to measure volume? What do we use to measure volume? So basically, what we use graduate cylinder, which is most common thing, burette, pipette, volumetric flask, syringe, conical flask, lots of things are there. Pipette. These deliver variable volumes. Pipette deliver a specific volume. Volumetric flask contain a specific volume. Uh-huh. Syringe, burette, and pipette. Syringe, burette, and pipette deliver amount of liquid with more precision than graduate cylinder volumetric flask and used to contain specific volume of liquid. Give it some thought. Why? Let's see. Which of the following quantities represent volume measurement? Which of the following quantities represent volume measurement? 15 m square. Okay, 2.5 is equal to 10 square m square. 5.77 liter per second. Liter L per second it is? How do you know? How do I know? Okay. Oh. So here metric prefix equals in the given quantities. Lady. Sometimes I forgot that I'm live. So M2. M stands for meter base unit of length. M square means square meter unit of area. Okay. No prefix is used here is in the base unit. It's 2.5 into m square m3. M3 means cubic meter unit of volume and 10 to the power 2 is equal to 100 is a multiplier decimeter. Decicendi, sorry. If written is 250, oh, 250 m3 is still use is still uses the base unit meter. 5.77 LS. L stands for liter, metric unit for volume. Milliliter is equal to 1 dm 3. What is that? Are you getting confused, Dean? Yeah, I guess. S stands for second, base unit of time. Means the liter per second, unit of flow rate. No prefix modifier. No prefix modifies the liter or second here. Common metric prefix for reference. Kilo K 10 to the power 3 centi C. Which of the following quantities represent volume measurement? Which of the following quantities represent volume measurement? 15 m square, m meter cubic meter. 15 m square. M square is equal to area. 2.5 is equal to 10. 10 square, what was the hecto? 100. And 3 cubic meter. Hmm. Give it some thought. Now I understand. Density. Density is defined as the amount of mass in a unit volume of substances. Density is defined as the amount of mass in a unit volume of substances. Okay. Density is defined as the amount of mass in a volume unit. Okay, sorry. The amount of mass in a unit volume of substances. In a unit volume of the substances. Amount of mass in a unit volume of substances. So density is equal to mass upon volume. So density is equal to mass upon volume. What is volume? Cubic meter. Mass meter. Density of solid and liquid are commonly expressed in either gram per cubic meter. The density of solid and liquid are commonly expressed in either gram per cubic meter, g gram, yes, gram per cubic meter or gram per milliliter. The densities of some common substances are listed in this one. Okay, it is no coincidence that the density of water is 1.00 gram per ml. No coincidence. The density of water is 1.00 gram per ml, gram per milliliter. So what is the density of water? 1.00 gram per milliliter. Density of water is equal to 1.00 milliliter. Gram per milliliter. Sorry, gram per milliliter. So gram was originally okay. The gram was originally defined as a mass of 1 ml of water at a specific temperature because most substances change volume when they are heated or cooled. Density are Densities are temperature dependent, and so temperatures should be specific when reporting densities. Okay, if no temperature is reported, was assumed 25 degrees Celsius, closer to normal room temperature. The temperature, density, and weight are sometimes confused. The terms density and weight are sometimes confused. A person who says that iron weight more than air, iron weight more than air generally means that iron has a higher density than air. 1 kg of air has the same mass as 1 kg of iron, but the iron occupies a smaller volume, thereby giving it a higher density. If we combine two liquids that do not mix, the lesser dense liquid will float on a dense liquid. We'll be live till 6 and then we'll do our other work, household work. Okay. Densities of selected substances at 25 degrees Celsius. एयर की डेंसिटी क्या होती है 0.001 ग्राम पर सेंटीमीटर सेंटीमीटर क्यूब सेंटर क्यूबिक मीटर सॉरी सेंटी क्यूबिक मीटर सी सेंट क्यूबिक राइट श्वेता यस balsa wood ethanol 0.79 water 1 ethylene 1.9 table sugar 1.59 table salt 2.16 iron 9.7 gold 19.32 okay the densest material in this list. 0.001. I'm sorry. Balsa wood 1.6, ethanol 0.79, water 1, ethylene glycol, ethylene glycol 1.09, table sugar 1.59, table salt 2.16, iron 7.9, gold 19.32. Okay. Some exercise. Determine density and using density to determine volume or mass. We'll do that. But first, I need to go and freshen up. We'll back today. We'll have to work also. I need to do some editings and then um. oh, okay. So basically, I have two mouse. One for the system, another one for my laptop. So sometime I forgot. I get confused. Okay, I'll come back soon.